Hello, discrete math fans. We're going to talk about variables. In mathematics, we use variables, things like x, in a few ways. It can be an unknown quantity that we'd like to solve for. This is very much the spirit behind what we do in algebra. Another way we can use a variable is to make a statement about all the elements in a set, and we don't want to be restricted to just talking about a single value. Now, as we go on, it's very important that we keep in mind variables do not have to be just numbers. In math, we deal with all sorts of different objects. In linear algebra, they can be matrices or vectors. You have random variables and probability. In this class, we'll use sets, and we'll even have other things like graphs. The uses are all over the place. Lots of different uses of variables. So when you see a variable, don't think just numbers. Now, when we want to think about unknown quantities that we're going to solve for, often we'll do it in the context of solving equations. Now, we're very familiar with the idea of solving for a variable in an equation. We'll write a problem using the language of algebra. Here's a typical example. We can say, is there a real number x so that 3x squared plus 13x minus 10 is equal to 0? Or usually we don't write it all out like that. Often we'll just say something like, solve the equation 3x squared plus 13x minus 10 equals 0. And we have lots of ways to solve this. We're not interested in discussing those methods here. Now for the second use, let's take a look at this sentence. No matter what odd integer we choose, if we square it and then divide the result by 8, we'll get a remainder of 1. Now let's rewrite this so that we'll use a variable, just like in the previous example. No matter what odd integer n we choose, n squared has a remainder of 1 when we divide it by 8. This is an example of being able to describe something about every element in a set. In this case, the set in question is the collection of all odd integers. Now this happens to be a true statement, but we're not going to prove it right now. We'll save that for later. Okay, that's all for now.